In this lesson, we're going to look at another application of vectors. So we talked about forces in our previous lesson, talked about resultant and equilibriant. Similar ideas can be applied to velocity. Right? Velocity is a vector because it's got a magnitude, a speed, and a direction. Okay, so we'll start with a simple one here. We've got a plane traveling due north at an airspeed of 900 kilometers an hour. Let's start with a compass. North is right there. East, south, west, just in case. And when I say the words due north, it means straight north. Here's my airplane. It's going straight north, and it's going 900 kilometers an hour. It encounters a wind blowing from the west. Okay, so when you see the words from the west, that means it's going towards the east. So I'm going to put it on my compass also, and make it a little bit shorter because it's less. It's only 80 kilometers an hour. Try and draw this a little bit to scale. And I want to know the resultant velocity of the plane. Okay, if I see that word resultant, it's the result of vector addition. So I have to think to myself, how do I add these two vectors? You could do tip to tail. Right now they're joined tail to tail. So I can move the wind up here if I want to. Or I could think to myself about the parallelogram method. There's my other one. Either way, if I go from the tails to the tips, or vector addition, my resultant is the green line. And I'm looking to find that. I can find that magnitude pretty easily because this is a right angle triangle, which means I can use Pythagoras. So a squared plus b squared equals c squared. And your right angle is down here, and it helps because it was due west and due north. If you use your calculators for that, you should get 816,400 for r squared. And if we square root that, we'll get 903.55. That's our magnitude. But again, velocity is a vector, so we need a direction. To find our direction, thinking about bearings, we usually start at north. So I kind of want to know what this angle is right here. I can find that angle again because this is a right angle triangle. I can use SOHCAHTOA. Got the opposite, got the adjacent. That's a tan question. So we're going to take the inverse for angles. And you should get, I got 5.08 degrees. Okay. So for velocity questions, what we're going to answer is, the question was, what is the plane's resultant velocity? I'm going to say something like this. The plane is traveling at 903 kilometers an hour at, and again we start north usually and say north, and we went 5.08 towards the east. Okay, and that's a bearings question. Okay, we're going to try another one, slightly more challenging because this one's not going to be right angled, but we can apply the same ideas to it. So read it, pause it, see if you can draw the diagram, because always the diagram is the hardest part. We got a plane, it's headed north 30 east. So we need a compass again. Okay, north, east. So north 30 east would be, start at north and go 30 towards the east, making a line like that. The speed is 800 this time. It encounters a wind of 75 kilometers an hour blowing in the direction, so blowing towards southeast. So when I see southeast, it means directly in the middle of south and east. So I'm going to draw it right in the middle, which means this has to be 45 and that has to be 45. And you find the resultant velocity of this plane again. So again, we can do vector addition, put it on the end, or if you want to, complete the parallelogram. It doesn't matter to me which version you like. We can go from the beginning to the tails to the tips. That's our resultant. Okay. Oh, I need my wind speed. My wind speed was 75. So that's 75. Okay, I'm trying to find R. Now this kind of looks like a right angle triangle. It's not. Okay. The idea we have to use, the idea of forces like yesterday, is find your C pattern. So here's the C. Okay. If I want to find R, I need to know the angle across from it. The angle across from it can be found right here by knowing the angle down here. So let's fill in some more numbers over here if we could. Okay, thinking about that original red line, we said it was 30, which makes this 60, which means this entire angle down here, 60 and 45 together, is 105, which makes our one at the top, based on that C pattern, 180 minus 105 should be 75. Doesn't look like a 75. 75. Okay. I now have two sides and the angle between them. That makes this a cosine law question. So if I want to find R, I'm going to use a squared equals b squared plus c squared minus 2b c cos the angle in between them, 75. You can put it all in your calculator at once because it's all on one side. Don't forget, like Pythagoras, you got a square root at the end. I got an R value of 783.94, the magnitude of my plane. We want to find velocity though, which means we need a direction. So I'm going to go back to my picture and I'm going to say to myself, well, the plane was going along the red line, but it ended up at the green line. So instead of going north 30 like we were trying to do, we actually ended up going over here. So if I can find that angle in between, I can say it's going to be 30 plus a little bit. This is going to be a sine law question because x is across from 75, and this 75 is across from r. So we can do sine 75 degrees, going with 783.94, and sine x is going to go with our 75 kilometers an hour. Probably shouldn't use 75 for both of those. Oh well. Okay, we're going to cross multiply. I'm going to leave this where it is, so I end up with my sine x by itself. I'm looking for an angle, so we're probably going to do an inverse, because inverse is for angles. So whatever this big, ugly, messy number happens to be, you can let your calculator do the work for you if you want to. Just figure out what that number is. And you should get 5.3 degrees. Okay, so therefore, the plane is traveling. Our magnitude was 783.94 kilometers an hour at, it was going north 30, but the wind pushes slightly more to the east, X amount, so now it's north 35.3 degrees towards the east, which is the 30 plus this number. Okay, so the old trick we've been doing, we're just applying it a new way with some vectors. And we're going to try another one. Okay, if you can, pause, try this one yourself. Okay, a plane is headed north 40 east. Right, compass, north, east. I'm going 40 towards the east this time. So I'm going to go this way. That's 40, which makes this 50 if I need it. It's 800 kilometers an hour. A west wind. That means a wind from the west, which means it goes towards the east. So we've got a wind pushing this way. Causes it to travel north 45 east. Oh, so they're giving us the resultant. They're saying after the wind pushed it, we ended up going a little bit more to the east. So my wind pushed it that way. I don't know how much the wind is, but I know this was north 45 east, which makes that little bit in here 5 degrees, right? That whole thing was 45. And the red one was 40. And 5 more. Okay, what do we want to do? Find the resultant speed of the plane. So we're still trying to find r. And we're going to have to find the speed of the wind. Okay, different kind of question this time. So I can't do exactly what I did last time because I don't have exactly the same information, but I can look for that C pattern again. I think I see one. Here's my wind, here's the plane, here's my wind. So if I knew the angle in the corner, which I do, we were told it was 50 based on the 40 up above, I can find the other angle up here. 180 minus 50 makes 130 degrees. Well, if I know two angles in my triangle, remember we did know the 5, it's stuck in here somewhere, there's a 5 down there, and we've got the 130 now. Whatever's left over has to be my third angle, which I think leaves me with 45 degrees. If you know two angles in a triangle, you always know 3. Well, if I have 3 angles and one on the sides, I can use the sine law. Okay, I can match up things that go together. Okay, angles across from each other, or sorry, angles and sides. So the 45 is actually across from the 800. Which one do we want to do first? Let's do the r first, the plane speed. The r is across from the 130. And now we can cross multiply and solve this one. So r sine 45 is 800 sine 130. I want to get r by itself. I'm going to divide out the sine 45. And for the resultant speed of the plane, we should get 866.68 kilometers per hour. I can do something very similar for the wind. I still have a pair. I can still use the sine 45 and the 800. And the wind is actually across from the 5 degrees. So I can do the same thing. Basically the same math twice here, just with one different angle. So W sine 45, 800 sine 5. We'll divide out that sine 45 again. And W should get, I get 98.61 kilometers an hour. Okay. Just take a little bit of practice. We're going to try one more. See if you can draw the picture. The picture is always the hard part. The trig comes down to one of our 3 things, either SOHCAHTOA, sine law, or cosine law. All right. Plane with an airspeed of 1,000 kilometers an hour wishes to fly to a city that has a bearing of north 40 west. Okay, in my compass. I've got a city that's north 40 towards the west. So this is where my city is. There is a wind blowing from north 25 east. So from north 25 east means north 25. The wind is blowing from here, which means it's going to push our plane here, right? And this would be 25. Those are opposite angles. I could put it there. Okay. In what direction should the plane head? Well, this black line that I drew is actually the resultant. It results from the wind pushing it to where we want to end up. So the real question was, where was the plane going originally? The plane originally was going that away, so that the wind would push it that away. Hopefully that makes sense. Okay. The plane was flying with a speed of 1,000 kilometers an hour. That's the plane. That's where it was going. The wind at 100 kilometers an hour pushed it over here. And oh, I should put that angle in there. The black angle was north 40 towards the west. So this angle right there is 40. Okay. Do we see the C pattern? Maybe, maybe not. Hopefully we do. I see the C right there. So if I can figure out this angle, then I can figure out the angle that I want. Actually, you know what? I'm going to use the other C pattern. Because I don't actually know what the red line angle is. But what if I use this C pattern? You know, that one I can figure out. This one I know is 40, which makes this entire angle 65, which means this angle over here, 180 minus 65 is what, 115? Okay. Now I've got something across from something else. 115 is across from 1,000. The direction the plane should head. Well, that's the angle across from the wind. So I'm going to do my x down here. It's a sine law question. Sine of 115 goes with 1,000. Sine of x is going to go with 100. This is part A. I'm going to cross multiply. 100 sine 115. Let's leave the 1,000 where it is. We have our sine x. We want an inverse, so we're going to inverse our big, long, ugly decimal right here, whatever that happens to be. And I'm going to get 5.19 degrees. Okay, that's my x. So the question said, which way should the plane head? Remember, the plane is trying to head this way along the red line, right? Oh, that's a green line now. Along the green line, which was less than where it ended up. So how do I get that green line? Well, remember, this was 40. We just figured out the x. So we're going to take the 40, we're going to subtract the x. So they should head north. Okay. They want to end up here, so I have to go a little bit less than that. So how about 40 minus that? 34.89 degrees towards the west. Okay, I took the difference between my 40 and whatever x was. Okay, part B, what is the actual speed of the ground, speed over the ground of the plane? So what that's asking for is, what is the resultant? Okay. We can figure that out because we have things across from each other. Again, we still have the, let's see if we get orange this time. We still have the 150, ooh, look at that, it moved. We have the orange across from the 1,000. If I want to get R is across from this angle up here. And our rule is if we know two angles in a triangle, which we do, we can find the third one. So we're going to take 180 minus our 115 minus the x we just found, which is 5.11. And that angle up there should be 59.81. Okay, sine law again. We still have the same pair we started with. That was our sine 115 and 1,000. Our new matching pair, we're looking for R, and R is across from 59.81. And good old cross multiplying again. R sine 115 is 1,000 sine 59.81. Can divide out the sine 115. And R is, I get 953.72 kilometers per hour. Okay. That's a trickier one because they kind of gave us the results in line without actually telling us how big it was. We had to think about that C pattern. Key thing here, the C pattern, right? The inside of the two angles add up to 180. Okay, I'm gonna get you guys to try a couple. The more of these you do, the easier they usually get. The pictures are always hard though. The math will come down to Pythagoras or SOHCAHTOA if they're right angled. Sometimes they are. Or sine law, cosine law if they're not. If you're stuck, come see me. Send me some questions. I'll help you out.